Okay, has everyone handed that in then? Yeah, I'll grade that and give it back to you tomorrow. But let's do it here. I'll write the whole thing. I hope at this point that the first thing you're writing down on your paper is you're writing down the equation as you eliminate the parentheses, as you do a step, right? So negative 8 times 3x is negative 24x. And then also negative 8 times negative 1 is positive 8. Are you starting to distribute the negative, right? Okay, so then we got the plus 4x. And on the other side, there are no parentheses or anything to eliminate, so I guess that's it. Then after that, we can add our like terms. So we've got a couple like terms here. That gives us negative 20x. And over here, is this 3 subtract 12 or a positive 3 and a positive 12? Yeah, what's the subtraction symbol for? Yeah, it's only for that 2x. It has nothing to do with the 12, does it? Okay, now, I don't know. Should we add 2x to both sides? We can do that. Add 2x to both sides. Get rid of that variable from the right-hand side. We have negative 18x plus 8 equals 15. And then we can get rid of the constant. Negative 18x equals 7. Now, when you divide both sides, make sure we divide by negative 18 so that this coefficient becomes positive 1. So positive 1x. And I think I'll put that negative on the top of the fraction, so negative 7/18 rather than 7 over negative 18. Everyone okay? Feeling better about these things and don't seem so daunting anymore, do they? Okay, so let's do the graph. Let's start with y equals 2x plus 4. So we're just making a table right now. However, let's start talking about this. Can you guys see in this equation the y-intercept? When x is 0, what's y? 4. So what is the y-intercept? 0, 4. Okay. And sometimes we say it's 0, 4. Sometimes we just say it's 4. Gets a little confusing. But this particular number, this constant, when it's written in this form, when it says y equals, right, this constant, that's the y-intercept. And you can look at it and just say, oh, well, 4. That's where it passes through the y-axis. Okay? Notice the coefficient of x. What is the coefficient of x? Say it louder. 2. Let's all try it. What's the coefficient of x? 2. Yeah, 2. Okay, notice that it's positive. What does that tell you about this line? Is it going up from left to right, or is it going down from left to right? It's going up. Okay, it's going up from left to right. So this line, it's going through the y-axis about there, right there, and it's going up, right? We can tell that. If we put other numbers in for x, say a 2, for example, we get 4 plus 4, which is 8. So 2, 8. That's going up, right? We put a negative 2 in. We get negative 4 plus 4, which is 0. Okay, so that's lining up. Everything looks good. So now let's start to kind of think a little more specifically about this number, which I always think of as a fraction. This thing isn't just going up, all right? It's going up in a specific way. See the 2 over 1 right there? Notice this line is going up 2 over 1. Up 2 over, and you can start anywhere on the line, okay? Up 2 over 1. Are you back on the line? Up 2. This number describes the rate of change of that line. it tells you how much it's going up in comparison to how much it's going over to the right. Okay? So that's the nice thing about having it in this form. And we'll talk more about this as we go. Okay, 5x plus 6y equals 30. This one is not in that same type of form, is it? Can you just see the y-intercept or the x-intercept? Can you just see the slope? Can you tell if it's going up or down real easily? You can't, okay? We like them this way to graph, but this standard form, we'll see why it's important too. So we can still graph it though. You know, we can still say if x is 0, what's y? Okay, so 0, 5. And then we can say, okay, what if y is 0? X is 6, so 6, 0. So even though it's in standard form, we can still come up with a couple of points, and we can still graph the line, can't we? We've been doing that on Alex for quite a while. We've been doing this for quite a while. You getting pretty good at it?
No.
No?
Yeah.
We will get better at it. Okay?
Don't worry.
All right. Don't worry. You'll get it. Now, last thing we talked about was the greatest common factor. Finding the greatest common factor of two numbers, like, I don't know, should we say 4 and, I don't know, 8. What's the greatest common factor? 4. Okay. What's the greatest common factor of 4, 8, and 32?
4.
Still 4? Okay. What if we have an x here, an x squared, and an x to the third power? What's the greatest common factor? 4x. That's right. So it's is the variable common? And then we just took the lowest exponent, didn't we? So there's our greatest common factor. Well, the reason we talked about this is we have to be able to factor the greatest common factor. Okay, now we've been doing this. Haven't we been doing this? Distributive property? We've been going, okay, 4x times 2x. 8x. That's it? 8x squared. Right? What's x times x? Okay. And then what's 4x times positive 3? Positive 12x, yeah. We've been doing that for some time. We've been multiplying using the distributive property. Well, now, instead of starting here and going to here, we're going to start here and go backward. Okay, so we're going to factor it rather than do the multiplication. It's kind of like dividing, but we'll see how it goes. All right, so let's start with a real simple example, and we'll go from there. Okay. So, let's see. 2 times a times x plus 2 times ac. So let's start off with, what's the greatest common factor? 1? 1 is a common factor. It is not the greatest common factor. What is it, Angel? 2a. 2 times a. See how that's common in both terms? Right? Okay, now, remember, I want to end up back here where I was. So if this is going to equal something, I'm going to have a set of parentheses here. And how many terms are going to have to be in this set of parentheses? What? That is correct. 2. How come? What are we starting out with? 2 terms. What do we want to end up with? 2 terms. We've got to have 2 terms in here. And what symbol is going to go in between these 2 terms? An addition symbol. So we just need to know what goes here and what goes here, so that if we use the distributive property, we'd be back where we started. Thomas, you gonna be okay, buddy?
Yeah.
Or are you just like, this is killing me? No. I'm not gonna make it today. You okay?
Yeah.
All right. Okay. So let's just see. What number do I need to have right here? 2 times what gives me 2? 1. Let's see, a times what gives me a?
1,
Yeah, just 1. And 2a times what gives me the x up here?
x,
Okay, now let's think about this. Would 2a times 1x give us 2 times a times x?
yes,
Okay, let's come over here. 2 times what?
1,
1, that's 2. A times
1,
1, that's a. And then, do I need a c?
yes,
So if I gave you this and said, multiply that out, please, would you end up there?
12,
Okay? And you can tell you've done it right. You guys are good at the distributive property. If you multiply this out, yeah, that's what we'll get. Do you have to show the ones? Or could you just put this?
You could just put that.
Okay. I'm going to put the ones in for now, just to be clear about what's going on. But as we get better at it, we probably won't so much. Okay? All right. Ready for a harder one? Too bad! Here we go. A lot of times when we say we're factoring, we say we're going to factor it out. Okay? So if it's not in it, can we factor it out of it? Probably not. So as we look at these greatest common factor, make sure it's in every term. Right? We can't factor it out if it's not in there. So let's start with the coefficients. What's the coefficient of each of these terms? 1. And what's the greatest common factor of 1, 1, and 1?
1,
All right, now, normally I wouldn't do this, but I'm going to put it down. That's, okay, 1 is the greatest common factor. So now let's go through the variables. A cubed, a squared, a to the 4th. Say it. A squared. X squared, x, and x cubed. X. M squared, m cubed, and m squared. M squared. That's the greatest common factor. Now think about this. If you put m squared here instead by accident, or excuse me, m cubed, would you be able to take m cubed, would you be able to factor it out of this term? It's not there, is it? You'd run into a problem. So keep that in mind. Okay, parentheses, big set of parentheses. How many terms will be inside here? 3. And what's going to go in between those terms? So a plus there and then a subtraction symbol like that?
Yeah.
Okay. I'm popular. Hello. Okay, thank you. Shannon, it's your lucky day.
I can have a look.
It's also your lucky day because you get to stay and learn. And there's nothing luckier than that, right? Woo! Okay.
So exciting.
Let's start with the coefficients. You know, what number is going to be at the first of each of these terms? 1. Okay. And we really don't have to show that, but we're going to put it in. Okay. Now, what I would do is I would just concentrate on this first term. All right, let's concentrate on making that first term. So what am I going to have to put here? So I've got a squared times what would give me the a cubed in that first term? 1, a to the first power, right? Okay. Now what about the x? X times what would give me this x squared right here? X to the first. And then m squared times, do I need to have an m to get the m squared? Okay, so you're saying if I multiply these two terms together, I would get my original first term. That work? Okay. Now let's concentrate on the second term. We've got 1 times 1 is 1. A squared times 1, isn't that a squared? And x times 1, isn't that x? And m squared times m, yeah? That's m to the third, isn't it? Okay? So now, if we multiply, we get the middle term. Okay, now the last term. 1 times 1 is 1. a squared times
x squared.
a squared. You're picking it up faster now, aren't you? X, so x times what?
X squared.
X squared, that would give us x cubed. And m squared, do we need an m?
No.
Okay. So, I'm saying that this original expression right here is equal to this new expression right here. They mean the same thing, right? If we started there and used the distributive property, would we end up back where we started? We would, wouldn't we? Okay? This is factoring the greatest common factor. I want you to try one. So, got your paper? I want you to write down this expression. Okay? Now, underneath, well, we could, you can do it here, but usually we put the equal sign here. What's our greatest common factor?
2.
2.
I did that wrong.
A.
Just A? A to the first?
Yeah, a squared.
A squared, okay. And
B. Squared.
B squared?
No, wait. No, just B.
Just B? Just B to the first, and then
And
C to Q.
cubed. So we're just taking the lowest exponent on our variables. Are you making sure that the variable's in both terms before you say it's common, right? Okay, now, put your parentheses down. How many terms will be inside here?
Q.
And what's going to go in between them? Okay, see if you can figure out that first term. Can you do it? Matt,
yeah.
come and see your nose. You're one of those proud nose people. Mason, you told me you did like an Alex assignment yesterday or something, but I can't remember what it was. So when we're done with this, come up to my desk and tell me again, and let's get it on your grade.
Okay.
Don't forget. You guys, when you give me something, make sure you write it on a piece of paper and hand it in, okay? So I have it. If you just tell me and leave, or give me a piece of paper without your name on it, bad things could happen. Okay, what do you say? What number's got to go right here? 4 or 2? 2. All right. And an A. And B to what power? Third. Okay. Third. And what about a Z? Now, we don't want a Z here, do we? Okay, so if we multiply these two terms together, we get our first term here, right? Okay, come over here. 2 times 1. We got a squared, don't we? A squared times 1, that would give us the a squared, wouldn't it? B times 1, that would give us b. Z cubed times z to the first, let's say. There you go. You factored the greatest common factor. That's what it looks like. Okay, now we're going to use this for something. A lot of times we learn something, but then we don't actually use it for anything for a long time. We're going to use this for something. I want you to look at these two problems. They're similar, right? Okay. So I guess my question is the 5s. Can I cancel the 5s? Can I just say, 5 divided by 5, that's just 1. I'll cancel those. Does that work? And then, let's see. 1 times 4 would just be 4. Well, let's see. 5 times 4, that's 20, and 20 divided by 5 is 4. That worked, right? Okay, cool. Let's come over here. Can I just cancel the 5s? No. I can't just cancel the 5s. I mean, if I did cancel them, would they be 1s, and then would it be 1 plus 4 is 5? Would that be correct? No. 5 plus 4 is 9, and 9 divided by 5 is definitely not the same as just 4 or 1 plus 4, is it? Can't be both ways, can it? So what's the difference? Why is it okay to cancel the 5s here and not okay to cancel the 5s here?
Your times multiplying that.
Yeah, there you go. We're multiplying here, aren't we? Okay, so these are called factors. Remember factors, they're numbers that we're going to do what with? What are we doing with them? We're going to multiply them, aren't we? Anything that's going to be multiplied together, that's a factor. And we can cancel factors. These are add-ins. We can't cancel add-ins or subtrahands or anything like that. What's the other one called? I forget. Anyway, we can cancel factors. So now, let me show you this one. 4a subtract 12 divided by 4. Can we cancel the 4s? Oh, I want to, though. But no, you can't. Okay? You cannot cancel those 4s. This 4 is not a factor of the entire thing that's being divided. It is a factor of a, but is it a factor of the negative 12? No. Okay, it's not a factor of that one. You can't cancel the 4s. All right? So here's what we can do, though. Look at the top of the fraction here. What's the greatest common factor? 4. Parenthesis. How many terms inside? 2. What symbol in between? Subtract. Okay. 4 times what would give me 4a? A. And 4 times what would give me 12? 3. So 4a subtract 12 and 4 times the quantity a subtract 3. Are they the same thing? They represent the same number, don't they? Now, see that 4 right there? Is it a factor of the entire numerator? Yes. Now they'll cancel. See the difference? See how everything up here had to be divided by the 4, not just the 4a or just the 12. So if you factor first, then you can cancel. And these are the type of problems you're going to be given. They're super easy, but oh so tempting. Can you see what we can't do? Can we just cancel these 3's? Or maybe these 3's? That's not going to work, is it? Okay. What's the greatest common factor? 3. What does that leave us with in the parenthesis? P plus 1. Yeah. Now see how they cancel? And that is your answer then, P plus 1. So if you factor first, then you can cancel the factors. So there you go. You want to try one? Too bad. Here you go. So 3x subtract 9x squared divided by 3x. Let's see if you will give in to temptation. Can we cancel the 3x's? Obviously not. I said that a million times already, haven't I? What can we do? What's the greatest common factor in the numerator up here? 3x. Okay, parenthesis. How many terms inside? 2. What goes in between? Subtraction. Okay, so what do I need right here in order to get the 3x, the first term? What if I just leave it blank? Would that be okay? Would 3x times nothing give me 3x? No, it's got to be a 1, doesn't it? Okay. And then 3 times what gives me 9? 3. And x times what gives me x squared? X. Okay, now, can you see what will cancel? Now, they don't both have to cancel. What's 3 divided by 3? 1, okay. And what is x divided by x? 1. They cancel separately. It's not like they have to all cancel or nothing, okay? So there you go. Here's our answer. 1 subtract 3x.
I got that right.
Yeah. Okay. We're working on set number 35 today. Those of you I said come talk to me, come talk to me.